Hello all. In this video, we're going to take a quick look at one of the more crazy and fun notations that Python has. This is absolutely optional in terms of working with Python. You don't ever have to use these, but if you go and try to read Python code, you will see these all over the place. So it's definitely worth your time to try to make sense of them. And I just find them, I don't know, I find them charming. They are so compact and so powerful and so useful, and I almost find excuses to use them when I don't absolutely have to. But like I said, it's optional. It's not something you absolutely need to know to do if you're just starting out as a Python programmer. And what am I talking about? I'm talking about list comprehensions. Very strange name. But they basically are a way for us to condense common patterns of iterating over loops into a very, very dense format. And so that's what I'm going to show you now. So we'll take a look. There are two basic forms of this that we're going to look at. There are others that extend this even further. I'm not going to get into those, so we'll just keep it simple with just these two. Mostly we're going to talk about this first one. So this is a notation that you just stick in the middle of your Python code. Oftentimes this will be part of an assignment statement. You'll say like LST equals, and then you'll write this thing, and it's doing all kinds of work. So the syntax, we have square brackets on the outside, which indicates I'm making a list here. But unlike what we usually do when we do that in our code, where we put data or variables inside the list, here we have a whole syntax inside the list that we have to unpack. So the syntax is that the very first thing inside the square bracket is an expression. It's followed by the keyword for and a variable, the keyword in, and a sequence, usually a list, but sometimes it could be a string, depending. The expression usually references the variable in some way, but it can modify it. So what is this? What does this mean? This is a condensed form of a multi-line expression that looks something like this. So you notice that we have for var in sequence in the unpacked version. For var in sequence, that's the same thing. That's the key, the heart of what's happening. We're saying, here is this sequence, maybe it's a list. I want to iterate over it for X in list. But then around that, what else is happening? We are calculating an expression, and then we are adding that expression to an accumulator list. So we're building a new list, and the values in the list are the result of calculating the expression over and over once for each value in the sequence. This is pretty abstract at the moment. Let's take a look at some examples. All right, so I've got our nums list. We used this in a previous video. It's just a list of numbers. We're going to do some things to it. So suppose that I have this list of numbers and I need to add 2 to every number in this list and build a new list. I don't want to modify the list. I want to build a new list that has these values, but each one has had 2 added to it. You know what would be really nice is if I could just say nums2 equals nums plus 2. We can't do that with lists in Python, but it would be nice. In the future, we're going to take a look at NumPy arrays where this kind of thing is actually possible. But we can't do it with lists. It is not an option. So I could write out a whole expression. I'm going to write out the unpacked version first, and then I'll show you the list comprehension. So I could say for n in nums, that's going to iterate over the nums list, and I'm going to make an accumulator variable. So nums2 is going to be an empty list initially, and then we're going to do We're going to add 2 to each one. I can do that inline. So I'm going to say nums2.append n plus 2. All right. So this will take the nums list. It'll build a new list the same length, where every value in the new list is the corresponding value from nums plus 2. So I can run this just to make sure you see, and indeed, everything worked out just fine. We do this kind of thing on lists so often that's why they invented list comprehensions. So I'm going to show you how to do this in one line. I'm going to build a list comprehension. So I'm going to say build me a list, and I'm going to have something here, and then I'm going to have for n in nums, which is the same. Oh, there's no colon inside the list comprehension. For n in nums. The thing that I put here, it's the expression that I added to the list. So this thing that I put in here for the append, that's what I'm going to do here. n plus 2 for n in nums. Oh, I need to print it. Yeah, helps print nums 3. Look at that. It does the same thing. It's extremely condensed. I can do all kinds of things with this. I could, if I have this number list, I could do any kind of arithmetic I want. I could do n squared and just see what that looks like. I'm going to get rid of this, which is its equivalent. So I can calculate the squares of every number in the list in one line. I could convert them all to strings or integer or to floating point. I could convert them all to strings and then add some laughter. 12, ha 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 ha. 16, ha 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 ha. 21, ha 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 ha. All the way through. Any expression that uses n is fine here. And in fact, it doesn't even have to use n. So I could just put hi. This expression doesn't even reference n, but it's still fine. I get a list the same length as the original, but with hi in every position. Why would you do that? Probably not. But adding 2 to every value in a list, adding 1 to every value in a list, making a sublist for every value in a list. These are all things that we might want to do. So that's the basic list comprehension form. You put the list you have that you want to iterate over. You make a list variable that's going to be values from that list. And then you put expression here which says, what do you want to do to those in putting them into a new list? And then it handles all the rest of building that new list for you, so you don't have to. That's our basic form. Because if I've blown your mind enough, you can pause for a minute, because the next form gets even crazier. The second general form. It looks similar. Have the square brackets on the outside, expression that's going to tell us what we're going to do to the elements of the list, for variable in sequence, so for piece of data in list or character in string, but we add an if Boolean expression at the end. So the first one, it almost like makes a copy. You give it a list of a certain length, you get a list of the same length. This one is doing something that we call in computer science filtering. So the only values that are going to end up in the final list are the ones from the original list that meet the Boolean expression. And then we'll do things to those values, but maybe not to anything else. Let's take a look at what that might look like. All right, so let's think of some nice simple cases. I'm going to just put n here. This is actually a common pattern you see. N for n in nums if n is greater than 20. Let's say greater than or equal to 20. I know there's not a 20 in there. Let's see what that does. It went through all the numbers in the nums list. It checked to see if this was true for them. For the ones that was false, it just threw them away. 12, gone. 16, gone. 21, oh, we're going to keep that. So that goes into the final list. 27 goes in. Negative 45 is gone. Negative 3 and 8. 94 we keep. 1 is gone. 50 is kept. In the expression here, I just said put the original value into the answer list. I just had an n here. I didn't do anything to it. But there's nothing stopping you from doing something to it. I could say 10 times n, for instance. And then it's going to filter and then do an operation on each value. So instead of 12, or what was it, 21, 27, 94, and 50, I've multiplied them all by 10 now. So this allows us to easily filter out values from a list. You could write this form all out. I think back in my notes, I have it. So this is the extended form, and if you wanted to unpack it, it would look like this. You'd have a for loop, you'd have an if statement, and the only things that happen to build to the new list happen in the if statement. So this is not a new concept, it's just a condensed notation. And we do it because filtering and copying a list or applying some operation to everything in a list are just things that we do so often in Python that we want to have a simple form to do that with. All right, you're really only going to understand list comprehensions if you sit down and do some examples. So start with an example that has been provided either in your reading or in the activity or by me, and then start tweaking it. See what you can do to change it and how that changes its behavior. And see if you can get some intuition about what it's doing. It's a very, very useful tool, but like I said, you can always write out the code to do what a list comprehension does. And it might give you a little bit of a boost of efficiency, but I wouldn't rely on that. I would generally just assume that it's not necessarily any more efficient than doing it by hand. All right, I'm going to stop there. I find this a fun topic, but as I said, it's kind of optional. You can do without it and still be a perfectly fine Python programmer until you get to a more advanced level, and then you probably want to master these. But if you ever see one in code, hopefully this will help you to decode what it is that it's doing. I will see you very soon.